Welcome to the MSDN show. In the last few episodes, we've talked about the .NET architecture, as well as the framework. Well, in today's episode, we're going to talk about C#. C# is a special programming language that was specifically designed to incorporate the base capabilities that the .NET architecture exposes. We'll assist you in understanding how this language can assist you in developing great applications. But before we get to that, let's go check in with Erica and the news.
Hello, I'm Erica Wiechers. Welcome to the MSDN News Update. The Internet Engineering Task Force is midway through an estimated 10-year effort to develop a new Internet protocol. The update is being driven primarily by the fact that the Internet, largely due to the explosion of non-PC devices in recent years, is running out of IP addresses. The codes assigned to every Internet-enabled device, allowing connected systems to find each other. The new IP standard is being referred to as IPv6. For more information, check out the show transcript for the URL to the full press release on the new IP standard, as well as for a link to download the IPv6 technology preview for Windows 2000. When Microsoft.com launched Search 2.5 back in July, they were also quietly porting their code to the .NET framework. Take a look at the steps they took to tackle that project with links to code samples and a version of the .NET-based tool at www.microsoft.com/backStage/bkst_column_25.htm. In October, Microsoft released SQL Server 2000 Windows CE Edition. SQL Server CE is the compact database that has the familiar feel of SQL Server with tools, APIs, and SQL grammar that minimize development time. For more information on SQL Server CE, including requirements to download, check out www.microsoft.com/SQL/productinfo/ceoverview.htm. On October 31st, Microsoft released the long-awaited production version of MSXML 3.0 parser. MSXML 3.0 offers a significant advancement over the MSXML 2.5 parser that was released with Microsoft Windows 2000, including complete implementation of the W3C standards for XSLT and XPath. More information about MSXML 3.0 can be found at msdn.microsoft.com/xml. Also on October 31st, Microsoft announced the first beta release of the next version of the Windows operating system, codename Whistler. The Beta 1 release will be distributed to key partners and customers, as well as to more than 200,000 software developers via MSDN. The objective is to gather feedback and enable compatibility testing. Both desktop and server versions of Whistler are expected to be generally available in the second half of 2001. For more information, check out the show transcript for the URL to the full press release on the Whistler beta. And that's been the MSDN News Update. I'm Erica Wiechers.
Welcome back. Now, like any platform you develop applications for, one of the primary things you need in order to get those applications to actually run is a language. Now, .NET has a special language we've developed for it called C#. With me here today is Anders Hejlsberg. He's a distinguished engineer at Microsoft, and he played a pivotal role in the C# language as well as in the .NET platform. You've all seen him before on the show, and so I brought him back to help talk with us about C#, what it is, and what programmers can take advantage of with it, and how it really affects the development of applications.
That's right.
So what exactly have you done with C# and when did you get started working with it?
Well, we've been working on C# for the last probably 2.5 years. It's been a design group of 4 people, and it's been, my major focus for those 2.5 years. There are many things we wanted to do with a new programming language. I think primarily probably is simplify life for programmers, make programmers more productive is ultimately what it comes down to. Now that gain in productivity sort of takes many shapes, but you could say that we've targeted with C# in a sense the power and expressiveness of C++, but with the ease of use and productivity of RAD languages. Some of the things we've done, for example, come into the categories of of giving programmers access to a better tool for writing components. If you look at how we write applications, or actually if you look at how we used to write applications, if you go back, say, 5 or 10 years, it used to be that applications were built as sort of these big monolithical things, and about the only interaction it had with the operating system, other than, doing file and whatever, was that the operating system would launch it, and then the user would interact with the application, you'd shut it down again. If you look at how we build applications today for the internet, it's actually a very different world. Apps are not monolithical things. Rather, they are sort of composed of a bunch of smaller components that sit in various hosting environments. You could, for example, take, you might have components that, for example, such as stored procedures in SQL Server. You might have controls hosted in a browser. You might have code sitting in an ASP page, business objects living on a middle tier. And you call sort of that whole congregation of components is what you call your application. Now, in order to make that...
In case, each one of those components is more complex than an application used to be.
Oh,
like
absolutely,
5, 10 years
absolutely.
ago.
And so to make them less complex to build, unlike big monolithical applications, you don't want to start from scratch every time you have to build one of these components. Rather, you want to sort of be able to inherit from something that already exists in the particular hosting environment. You want to inherit from a base control. If you're writing a control in a browser, you want to inherit from, some core business object class if you're writing a business object on the middle tier. And you want to expose things from these components, like properties and methods and events. You want to say something about how they integrate with the hosting environment through attributes that you attach to the component. And you want to be able to write documentation for the components alongside with the component.
All this is just standard object-oriented programming that's been around for quite some time, with Smalltalk.
Absolutely, and it's not that you can't do these things today. But if you look at the programming languages that are in widespread use today, they don't actually really support component-oriented concepts. If you look at, say, C++, if you accept, that when we talk about components, it is very common today to think of them as having properties and methods and events. But if you look at C++, there's really only the notion of methods there. There are no properties, there are no events. Now, you can emulate them by having naming patterns that says, for a property, instead of having a color property, you have a getColor and a setColor method. And instead of having, events as a first-class member in a class, you have interfaces that, someone wanting to receive the event have to implement. And so there's a bunch of housekeeping that you have to go through in order to do that.
C++ is based on C, and it's just like a preprocessor thing.
Yes.
So since C didn't support that inherently, C++ couldn't inherit.
I actually sort of think that what you're seeing is an evolution from C to C++ to C#. From C to C++, the concept of object-oriented programming was added. If you go from C++ to C#, I would say that the concept of component-oriented programming has been added. And there's really an analogy, just like you could do object-oriented programming in C instead of C++. So can you do component-oriented programming in C++ instead of C#. It's just harder. It's a lot harder in C to do object-oriented programming. You have to manually lay out your vtables and do all sorts of housekeeping. And the same is true in C++. You can write components, but you have to manually sort of have naming patterns for your properties. You have to manually implement event syncs. You have to have external idle files where you describe your hosting attributes. You have to have external documentation files and so forth. And we're really just sort of taking that next logical step that reflects how people write applications and folded it into the language. So you get one-stop programming, so to speak.
So then what were some of the initial objectives from a mental thinking standpoint when you first started this project, the problems you wanted to solve and the directions you wanted to take this new language?
Well, I think, as I said, the component orientation is one thing. I think another key factor is simplification. Just make it simpler to write application. Don't make programmers do the housekeeping that the machine could do for you. Now, a lot of that simplification lies in the .NET runtime itself, but a lot of it lies in the language as well. And basically, in the end, what we do is we give you more time to focus on the algorithms, and we let the system do the housekeeping. I think a couple of other things that were very key was sort of the realization that we can't just tell people to throw away all of their existing code. We have to find a way to leverage not just your skills, but also the code that you've written before, that exists already. So in terms of leveraging your skills, we've tried to stay very close and very true to the underlying syntax of C++ in C#. So any C++ programmer will immediately feel familiar and at home with C#.
Now, was that one of the original thoughts you were going to take and do something that was one step above C, or did you originally think, let's just throw out everything, let's just start with a brand new language?
Well, I think we did start with a blank slate, but we knew that we wanted, C and C++ programmers to feel familiar with this language. That, of course, meant that, sort of statement structure, we weren't going to go change that from being curly braces to being something else. So there was sort of a foundation laid there already. But there were some other key tenets, like allowing you to write robust software. And that means things like garbage collection, exception handling, type safety, that fundamentally alter how you design the language and are very hard to come in and sprinkle on later. I mean, in C++, one of the strengths of the C++ language, but also sometimes one of the hard parts about it, is the fact that, there is no type safety. Now, if you know what you're doing, that gives you tremendous power, but if you don't, you can get in trouble. It is very easy in C++ to have a dangling pointer. It's very easy to override over the end of an array or to have an uninitialized variable and so forth. And we wanted to solve some of those problems. And I think that you can't just start with C++ and sprinkle it on. You really have to sort of take a step back, but then continue, but create your design in the spirit of C++, which is sort of what we've done.
What about other languages? Did you look at what other languages are doing, whether Pascal, Modula 2, and
absolutely.
Forth, and borrow things from those?
Oh, we looked at, I come myself from a strong Pascal background, so naturally, looking at Pascal, Modula, Operon, looking at Smalltalk, looked at Java, looked at C++, looked at a whole range of languages, that exist and are in use today, more or less widespread. So.
What are some of the features in those languages you felt that they were doing something better than C and C++ were that you needed to bring into this new language?
Well, I think one of the things that I, for example, always have liked about Smalltalk is the notion that in that language, everything is an object. Now, this gives you tremendous simplification because it doesn't matter what piece of data you're holding, you can carry it from point A to point B as an object. Anything can sort of operate on it generically. You can put it in a container just typed as an object. Now, in the actual implementation in Smalltalk, there are some pretty heavy performance overhead associated with how they do it. For example, in Smalltalk, when you operate on floating point numbers, for every new number you produce, when you add 1.0 and 2.0 together, you allocate a new object that contains the value 3.0. And that's, of course, a very expensive way of doing it. Now, we've done some innovative work in C# that allows you to get the same benefits, but without the overhead. As long as you treat your floats as floats, as you say, or double, you use the type double, there is no cost. But you can treat them as objects. And at that point, they get heap allocated, but only if you do so. So there's some nice unification there that gives you, a lot of the benefits without the performance overhead.
What about some of the structures of the end result of what happens out of C#? So you got this, text file C# program, and then you compile it. What about some of the issues of the compiler itself? How are some of the designs built into that to be more effective and use what some of the other languages might have done? And then even the binary executable that comes out at the bottom end.
Well, we've done some things with respect to just how you write your code. If you're a C++ programmer, you're of course familiar with how you have in C++ a separation of declaration and implementation. So you write all your declarations in H files that you then pound include in other modules, and then you write your actual implementation in CPP files. In C#, you write both in the same place. So you write your declaration, and then you immediately write your code in there as well.
Then what if you need to take and use some values declared in your main file in some other file?
Well, so what happens then when you compile is that instead of just producing x86 machine code that has nothing but the executable code in it, we actually produce code that has we produce an output file that has both the code and the metadata, the symbol tables, or the associated symbolic information. In a sense, the code becomes self-describing. So when you want to use one piece of code from another piece of code, you simply reference that other code. And the code is self-describing enough that we know what classes are in there, what members do the classes have, what are the methods you can call, what are the properties, what are the type names, et cetera, et cetera.
So would that be like you're pointing at the .obj file or the .exe file?
Well, you're actually, the format we use in .NET is a PE format. So you could point at another exe or at another DLL. We call those assemblies now, and we basically use that word sort of broadly to describe these super DLLs, if you will, that contain not just code, but also information that talks about what is in the code, and also indeed talks about what other assemblies this code references.
Mm-hmm. And by code you mean binary code or executable code?
Well, actually, we don't produce directly executable x86 machine code. Rather, we produce MSIL, which is the intermediate language that .NET defines and that it provides JIT compilers for.
Okay, so you've got an executable per se that is this intermediate language as well as the metadata associated to it. And then if I want to use that one in my application, I just point to it and says, hey, I want to borrow these classes, borrow these objects, and use in my own thing like that.
Exactly.
Now, this reminds me of a problem I've heard a couple of people mention, is that there's a concern that if they've got an intermediate language, that the potential exists that someone else can take and grab that file and decompile it and get back to the original source code, and therefore know all the intellectual property rights associated with the developer.
Right.
What are some of the issues there?
Well, first of all, you can actually do that with DLLs today. It's just probably a bit harder. But you could take, a DLL containing x86 machine code and decompile it into assembler, at least. You can do the same.
I used to do that on my Apple II all the time.
Exactly. Well, I'm guilty of it. Yeah. But you can do the same with .NET DLLs and decompile them into MSIL. They're not decompilable directly into C#, although you could probably also finagle that problem. It's much harder. Now, the thing that's different is that there's a lot more symbolic information associated with the code produced by C# or with an a .NET assembly. For example, you can learn from the code what classes are in here, what are their members, and so forth. It's a tough problem to solve because there are so many advantages to having the code be self-describing, but the fact that the code carries around a description of itself also makes it somewhat easier to understand what the code does with a decompilation tool. Now, we're looking at this problem. Basically, what we're looking to do is build what's known as an obfuscator, that will go in and mangle your code around so it becomes next to illegible, yet still preserves the same public interface.
Yeah, because the problem you've got is that you want that code to be understandable by compilers and so forth like that, but you don't want them to be understandable at that same level by individuals who are taking and write these decompiled programs.
Exactly. Now, I do want to point out that for a small application, it might actually be possible for you to decompile it, and given enough time and resources, you could even understand what it does. For a real-world application, this is quite an undertaking, and in reality, you're probably better off running the app, understanding what it does, and then writing a copy of it. You'd get there sooner. So
probably write a program anyway, right? Because you're a better programmer, right?
Yeah.
What are some of the issues about C# that our audience might need to understand in order to figure out whether they want to start implementing the next project in C# or not?
Well, I think first of all, you need to think about where you're coming from. If you have an existing body of code, and let's say it's written in C++ already, probably your shortest path to moving that code to the .NET framework is to use managed C++, the C++ compiler that we're shipping with .NET. However, if you're looking at writing new code, be that either, sort of new modules, larger modules that go into an application, or a whole new application, and you are skilled in C++, then I would recommend that you look at C#.
So we're not necessarily saying that everyone needs to rewrite their applications in C#. We're saying that people need to understand the type of project they're currently working on, whether it's an existing project, legacy code, and sometimes write some of those components in C#, but they can use C# and C++ interchangeable?
Oh, well, absolutely. First of all, If you just have existing code that is written, say, using really any language that's supported by, the Windows platform today, compiled either into COM components or into DLLs, we give you great interoperability with that code. Now, if you're writing code specifically for the .NET framework, new code for the .NET framework, you can indeed write it in any of the languages that are supported by the .NET framework. We're going to be shipping 4 languages with Visual Studio.NET, C#, C++, Visual Basic, and JScript. But in cooperation with the industry and academia, I think at latest count, this may not be a precise count, but I think the total is at about 17 different languages now targeting that platform, ranging all the way from, APL to COBOL.
What about something like Fortran?
I believe there is work in progress for. I don't know precisely who's building that Fortran compiler, but the key thing here is, and we've demonstrated it many times. But you could write, a base class in C#, inherit from it in C++, and use a VB program to create instances of it. It's that seamless to do that to do that interoperability between the different languages, and that's something that I think really sets apart the .NET framework from other, other competitive products in the industry.
And that it takes and allows multiple languages to interoperate on level footing.
Yes, but at a very high level. I mean, you could argue that today languages can interoperate, It's just at a very low level with, DLL entry points and structs with pointers in them or whatever. And we're talking about a much higher semantic level, at the object-oriented level, if you will, with classes and interfaces and so forth.
Is C# considered a proprietary language for Microsoft?
Actually, no. We in cooperation with industry partners, in particular with HP and Intel, we made a proposal to a European standards organization called ECMA earlier this year to standardize C# and something called the CLI, which stands for the Common Language Infrastructure.
And that's similar kind of to the C runtime and the VB runtime and stuff like that?
Well, actually, it is a large subset of the .NET framework. It is, in a sense, all of those parts of .NET that could be moved to other platforms, meaning that, for example, it does not include, any Windows-specific UI library, for example, because, that would not be of much interest to other platforms.
Things like memory management and
absolutely, memory management, I mean, a large portion of the class library is included in the CLI. We made this proposal to ECMA in September. It was adopted at an ECMA meeting, and work is now underway to formulate these 2 standards, one for C# and one for a common language infrastructure.
So what does it mean then for C# to be a standard through ECMA then?
Well, it means that other industry partners can, and most likely will, go implement this language on different platforms.
So if I was someone like like Boeing or something like that, and I had some, old PDP 1170, and I wanted to get C# running on it, I could take it unto myself to use the ECMA standards and create my own compiler for my old legacy computers if someone else wasn't already going to be doing that sort of thing.
Absolutely. Now, C#, now the 2 standards are actually submitted hand in hand, and C# itself currently doesn't specify a runtime library. Rather, it relies on the .NET framework, or when we're talking about the standard submission, it relies on the common language infrastructure to provide the runtime infrastructure and the class libraries for the language. We're currently working with the standardization organization and our industry partners to determine precisely what the lowest bar of requirement is going to be. Obviously, the CLI will be divided into various levels. Indeed, the submission that we gave to ECMA is divided into various levels, starting at a very low kernel level, where really you just have some of the core data types, some very, simple things like arrays and whatever, all of the atoms are there, but the molecules are not necessarily there. They're built in higher levels of the stack, and so for embedded devices, you could actually end up with a very lightweight environment that you could move to different platforms.
So a version of C# that I could run on my wristwatch or something like that.
Well, in theory, yes, or your refrigerator, or wherever you.
And that that, to a certain extent, is the whole goal of the .NET framework, is allowing this programming infrastructure to exist on multiple different types of devices, so that one device can talk to another device, and borrowing the services and support across them, either connected via network or Bluetooth or something like that.
Well, yes, that's part of it. I think now it's important to keep in mind, though, that when you talk about distributed applications or devices talking to each other, that the infrastructure that we put in place in the .NET framework, and indeed also in CLI, actually does not require on .NET being present on both ends of the wire. Rather, the architecture that we recommend and indeed lead you towards when you use our class libraries to build your applications is entirely based on industry standards like XML and SOAP, and you can indeed, implement it on, a Linux box, say with Java and an Apache web server, and build that other side of the equation using other tools, if you like.
So in my C# application, if I was writing it to connect to an external service, I could treat that just standard C# calls and so forth, and then external service running on a different machine, could be, Amazon.com or some other system like that that's not running Windows, not running C#.
That is precisely the whole vision of web services.
And all they have to do is just implement SOAP.
Yes, well, basically what we would do is we would use the existing internet infrastructure, meaning, the carrying protocol is HTTP, the payload is SOAP formatted XML, and indeed there could be anything on the other side of the wire. Now, we have the ability to make this XML and these SOAP calls look like objects with methods when you access them from C#. But and we give you sort of all of the infrastructure to turn method calls into XML SOAP bodies that go across the wire and come back and get unpackaged again, through all of the serialization infrastructure that we have in the .NET framework.
Now, you were saying you've been working on C# for a couple of years now, and XML had about the same life cycle, so that means neither one of them kind of knew about the other when they got started.
Well, XML's probably been around a little longer than that. SOAP is fairly new and has evolved in parallel with C# and in parallel with the .NET framework, and it's, we are actively heavily involved in these standardization bodies through the W3C, and we are tracking that, and we'll continuously adhere to the latest standards.
So was this level of interconnectivity between SOAP and XML, was that originally one of the aspects of C#, or was that something kind of evolved as the language evolved?
Well, I think there's actually sort of a separation here. Most of the infrastructure that is required to do XML and SOAP is provided by the .NET framework, not by the C# language. Now, the C# language builds on top of the .NET framework and gives you great access to these things. For example, through this thing that we have in C# called attributes, you can directly in your code express, what is the mapping from this class instance to an XML formatted body that goes across the internet. So I can, for example, say, for this field, I would like this field to become this XML element with this name. I would like this class name to become this tag name in XML, and so forth. And we allow you to do that directly integrated in your source code through attributes. So that's one of the things that makes it a lot easier to use XML with C#.
So they just fit really well together.
They do indeed, yes.
Yeah. When thinking about the design of an application, is there a different way I want to conceptually work my application up in order to use C# better, or is it just the same sort of mental flow that I'd normally have in a C application?
Well, I think one of the key tenets, is that you are now programming in a deeply object-oriented fashion, and even in a component-oriented fashion when you're using C#. So you might tend to think of your application design a little differently. Now, if you're using C++, you would probably still think of, writing objects and so forth. When you're writing in C#, you may, for example, think about, geez, am I writing a component? Well, is this component going to need to have the ability to go on a toolbox in Visual Studio so I can drag it onto a form or onto a business object or onto a web page? And, is it going to be then shown in a property inspector? Well, geez, then what properties should I have in there? And how do I control what goes in the drop-down list? And should I have a special editor for that? Now, we give you all of that infrastructure, but it makes you think about your design differently than you traditionally would when you just wrote C++ code.
So for the most part, it's just you're still writing an application. You just have more capabilities to expose depending on how you embellish your application.
You could say that, yeah.
What about the whole notion of being more of a service-oriented sort of thing? So I'm writing more almost a non-GUI application running on a server, and I'm going to be attacking it with a web client and coming at it asking for responses to track a package or something like that. Does that change the mindset at all, or is that still just the same server-side orientation?
Well, I think it in a sense makes you think a little bit more about abstractions in your applications. You know, you would tend to think more about how do I layer my application into a business logic tier and a presentation tier? How do I put APIs on my business logic such that it can either be used by my presentation logic to present HTML or a client-based UI, or even just be direct entry points for web services that go over the web. So there's, you tend to think about that a little bit more, I would think. So as I said earlier, you're not just writing these monolithical things anymore.
Do you see this as lending itself more towards people using other people's components a lot easier than they have today? I remember, when I used to work at Boeing, we had this big thing going on about code reuse. And we had to make sure that any application we wrote, any code we wrote, was specifically designed for code reuse. And while in thought it sounded like a great idea, in practice it never quite ended up being utilized that well because it was just really hard to reuse someone else's code. Do you think this might actually enable that better?
I think it will. I think that the key operative here is actually, for that, is the .NET framework. It is the fact that we have defined this substrate upon which you can build components, and we say a lot about how you put them into classes, how you make them components. We give you strong design guidelines, and indeed the whole framework serves as an example of that. But key to it is that it is uniformly accessible from a variety of programming languages. So the problem you talked about here, for example, if some guy is writing some language or some library in COBOL and you want to use it from C++, it's going to be very hard. We're actually giving you a substrate that allows you to do that kind of interoperability. So you definitely stand a much better chance of having your components interoperate. Because in reality, the thing that's often hard for people is that components are written with different design philosophies or at different abstraction levels, and that's what confuses people. They are not accustomed to this style of API, and so they get lost in the infrastructure. They can't see the forest for the trees, if you know what I mean. And so by saying a lot about how you write components and giving you a consistently available API and infrastructure for writing these components, you stand a much better chance of getting better reusability.
Okay. Well, I think that sounds like a pretty good explanation. Are there any final closing words you think are important for an audience to understand in order to grasp the architectural importance of C# as a language?
Well, I think the best way to do that is to play with it yourself. So I would urge people to download it from our site, and I'm sure you could give them the address. Download it, play with it, write some examples, join our user groups or news groups, talk to other people that have used it, see what their experiences are, and I think you'll have a good time.
Okay, I'll be sure to put a link at the bottom of the transcript to where they can download the current version of the C# runtime, the .NET stuff that we gave out at the PDC, and I guess we have another version.
Beta 1 coming out.
Beta 1 coming out pretty quick, as well as a link to the news groups that you mentioned.
Yes.
So make sure you send me some email with those news groups in it, and I'll set that up.
All right.
Well, thanks a lot, Anders.
You're welcome, Robert.
I know I appreciated talking with you, and I hope our audience appreciated hearing from someone that actually helped design the C# language and what that means for developing applications with. So after this short break, we'll come back and actually talk with a programmer who's been developing applications using C# for quite some time now, and find out what he thinks about the language and any hints he might have that help you develop your own applications using C#. So stay tuned.
Man, it was like heavy metal trash cans singing along the groovy interstices of some Hepcat webman. Screaming through the purple sirens of the city, awake at 4:30 a.m., moonlit night blanketing the yard, dogs howling in the trees, and I was spinning through sites, plowing through pages, growling through the gifts, my eyes like tiny red raisins, blotchy, wrinkled corneas, flat, featureless, hypertextual boneyards of unmeaning, the waves unheard and the flat files flushed at the mercy of the hellion webmaster of Freddy's cow insurance homepage. When my browser crashed through some weirdo mysterioso packet barrier man, and there I was on this cool page, a sweet, delirious, munificent page, tagged and titled before and after, tables nested deep and deeper in the collective subconscious of the killer site and its creators, seeking enlightenment in dynamic HTML, seduced by the object model of 1,000 nights of ecstasy, besmooched by Scheherazade, besought by the cyber cam in the valley of the shadow of the moon of Mars. And there it was, just now visible as it blasted through a cut-through black, uncover down, split vertical out transition. Filters screaming, letters a mile high. Flames mounting in my medulla oblongata, the words flooded my brain, man. Worldwide live, the web the way you want it.
Welcome back. We're now going to take and deal with some of the programming aspects associated with C#. And to assist us in understanding some of that, I have with me a good friend of mine, Jeffrey Richter. Now, Jeffrey happens to be a programmer that has written a number of programming books. This is the most current one, is called Programming Server-Side Applications for Windows, Microsoft Windows 2000. Now, you also are a consultant and you have your own company, Wintellect.
Wintellect, right.
I suppose you have a website.
Yes, at wintellect.com.
Okay, so
we specialize in training, debugging. A little ad.
Okay. Now, I understand lately you've been doing a lot with C#.
Yeah, it's been over a year now that I've been pretty much programming exclusively in C#.
No, wait, for a year now. I thought we just released C#.
Yeah, but I've been on the inside track, if you will, within Microsoft, and set myself up with a little office in Building 42, and have been studying it and working with .NET for over a year at this point.
So Microsoft was kind of assisting, because you're not a Microsoft employee.
Correct.
They were just assisting you understand C# as language so that you could be writing more books like this one.
Yeah, they're hoping that I'm writing more books, and you know, I kind of help with, I find bugs, and I sit in some spec meetings and things like that and talk to people. So I kind of feel like I've had more of a part than just writing about it, but actually contributing to it to some degree as well. So I can tell you, you know, when I first started, the first thing I was interested in was this new language that I'd be using to write all the code that I knew I'd be writing for, you know, the foreseeable future. Let's put it that way. And coming from a very strong C++ background, I would say I felt pretty proficient in C# after 1 week of reading the docs and the programming reference and so on. And I was really able to produce some useful stuff within a week.
After just 1 week?
Yeah, after just 1 week. Because it is very similar to C++. You know, the braces are there the same, the return values are the same, parameters are the same. Everything, a lot of things are pretty much the same.
You just kind of lose some of that freaky naming convention they've got going on with objects and destructors and constructors and double colons and junk like that, right?
Yeah, yeah. Instead of double colon, everything's a period, and instead of arrows, it's a period. So they've simplified the language quite a bit. So it's been really easy for me, and it's still periodically I still have to go back to the language reference and maybe look up how to overload an operator or some general, you know, more obscure things I'm less likely to do when I write programs. But for the most part, it's just very natural to me now. It really just flows.
Now, since you've been working with it for a year, have you noticed the language itself evolving over that year time, or was it pretty much the same a year ago as it was today?
I say it's pretty much the same, but there's definitely been little tweaks, and there's certainly been very responsive in the beta cycle. There was a lot of things about non-deterministic destruction of objects and things like that. And so the base class library has added an iDisposable interface that I think will appear in beta 2, not in beta 1, and C# has added some new language construct to help you get something closer to deterministic destruction of objects. So I would say that Microsoft's been pretty closely following what people have been saying about the language, and they have been responsive at trying to add new things to it. I also know that in the future, after version 1, they're going to be adding generics, which is kind of like templates in C++, and I'm sure C# is going to evolve in order to support those. And actually, when it's in the common language runtime, all the languages will be able to use generics.
They'll do part of that, and so they're since it's a common language runtime, have access to all that functionality. Now, what do you think of C# as a language overall?
Well, as I say, it's very similar to C++, and so I felt right at home with it very quickly. It's very, very clean. I would say it's very clean. You know, coming from a C++ background, especially as a Windows C++ programmer, ANSI owns the C++ specification. Microsoft wants to keep tweaking to the language in order to expose features that are in Windows and make them kind of look like first-class citizens in the language, but they never really get there. And Microsoft keeps adding things like underbar try and underbar finally and underbar decal spec. Right, in C++, right. Yes. So the language looks kind of, well, hideous after a while. And you never quite know, you know, with things like const or whatnot, does the star go in front or the star go after when you're declaring a pointer to something, or God forbid, a constant pointer? You'll never figure out where to put those modifiers on the line. I always have to look that stuff up. So in C#, since Microsoft has created it prior to proposing it to ECMA for standardization, it's really clean. There is nothing that starts with an underbar, for example. And of course, since there's really no pointers per se in the .NET runtime, therefore you don't see asterisks and ampersands and those type of adornments all over your code. So when you just look at it, it just looks clean and crisp, and you just have a really good feel.
But don't you feel you're missing? I mean, like when I was programming in C, I mean, I know I love doing things with pointers. I mean, you just had all sorts of fun things you could do with them by reclassing them and using pointer arithmetic and junk like that. Don't you miss that with C#?
Well, I have to admit, I've always been a bit of a bit twiddler myself, and sometimes I kind of miss that. Of course, with C# and the .NET framework in general, you can always interoperate out to some other language. So if I really need to do that type of thing, I can write it in C++ instead of in C#. C# also does offer an unsafe keyword. So you can make a method and say this is unsafe, and you can have access to pointers and do some direct memory manipulation in that. Although I personally have never actually had to use that. As far as fun goes in coding, the .NET framework in the base class library offers just a ton of features that make programming fun. So while I don't have things like reserving virtual memory and sparsely committing it or working with memory map files in the .NET framework, at least not directly, can do it through interop, there's still other things like serialization and web services and other things that are fun to produce really valuable applications, really powerful and rich.
You know, in your classes you're teaching and stuff like that, are you doing any C# classes yet?
Yes. In fact, just this week I taught my first .NET programming with C# class, and there were 2 people in the room that were Visual Basic programmers, not even object-oriented programmers. And I didn't really give an introduction to C#, the language per se, because really I mostly focus on the common language runtime in the base class library. And I'll say more about that a little bit later. But the VB programmers during the labs, they had very little trouble picking up the C# language and actually doing them and being productive. And I was quite surprised myself.
And some of that would be because in C# you've just got the name.name.name.name rather than the name arrow name dot name arrow name dot star asterisk parent pound and all sort of junk, which they wouldn't have used in VB.
Correct.
So the format looked fairly similar to them.
Yeah, fairly similar. Of course, they had braces instead of begin and end. You know, that may have thrown some of them. But I think it didn't take them more than 5 minutes or so to get over that and be able to be more productive.
Mm-hmm. Now, from a corporation standpoint, if a corporation was coming to you and wanted to have a class on C#, so I got to find out whether they should start thinking about moving some of their development efforts over to C#. Is that something you'd recommend that they do, or in what stages do you think?
Well, certainly it depends on, first they have to decide they want to adopt the .NET framework as their development platform. And I think there's a lot of value there, and there's no question for me that that's really where I want to be. If you're developing for the .NET framework and you are writing new code, it just seems to me like it's a no-brainer. It's really easy to pick up, the language is crisp, you're very productive in it right away, so I would strongly suggest C#. I also personally believe that a lot of VB programmers, VB6 programmers, will migrate to C# more so than VB7.
Why is that?
Because I think C# is, it just exposes more of the functionality in the common language runtime to you. You have a little bit more control over the code and the way that you express it. You're more directly talking to the runtime, and that gives you more power.
Mm-hmm. Of course, neither one of us are VB programmers per se, so we're obviously going to go after C. So I suppose we're kind of biased from that standpoint.
Yes.
Now, what are some of the aspects of C# that you really like as a language, some of the more simpler, just clean programming aspects?
Well, mostly it's the stuff that's been removed. The things like, well, C# doesn't allow you to declare parameters as const, and you can't have a const instance method, which you could have in C++. I know some people will think of that as a really missing feature of the language. But the fact is, in C++, const could always be casted away, and then you're able to do anything within your code anyway. Since C# doesn't really allow you to use const and put it there, it's, again, just clean and easy to follow. You know, I think I should say that to me, what's really interesting about the .NET frameworks is you have this common language runtime that defines how objects behave, or how you create types, and what defines the behavior of those types. Then you have the base class library, which is, of course, this enormous library that just gives you access to a lot of things, so you don't have to rewrite everything over and over again, reinvent the wheel, if you will. The language that you choose is really just a personal choice. And I've chosen C# because it's a really good high-level language. It lets me talk to the framework. But really the best language to use the .NET runtime in the base class library would, in a way, be the intermediate language, assembly language.
Assembly language returns, huh?
Yeah, assembly language returns. I mean, that's going to give you full access to the underlying platform that's underneath, but it's difficult to be productive in an assembly language environment. There's so many individual lines that you must write yourself. So C# is like the next level away. And there are things in C# where the designers of it, such as Anders, has decided that this wasn't a really commonly used feature, and therefore they didn't necessarily expose it in C#. So in some cases, I might resort to another language in order to get access to a runtime feature that C# doesn't provide. But in general, C# is the highest level language that allows me to do as much bit twiddling as I feel that I need in this environment and be really productive.
But just not, not all the bit twiddling, just, but most of it?
Yes.
Okay.
I mean, it's very rare
Yeah.
that I need to get access to something else that C# doesn't let me get access to. And this is another thing that I think it's just very easy for people to forget, is that when you want to get access to some feature that C# or some other language for .NET doesn't provide you, you can switch to another language. Just code that method up, maybe a static method in a class in APL or in COBOL or whatever language of your choice, or maybe derive, and then implement some instance method in some other language, and that language maybe does give you access to some feature underneath. So I think that's a very powerful paradigm that we never really had before, to choose the best language for getting the job done.
I bet some of our audience might want to see some examples of some C# code to understand some of the things we're talking about. You maybe have some examples you can show us?
I did bring with me a source code file that just has some sample code in it that I could kind of walk through a little bit. And after the session, I'll give it to you. You're welcome to post it on the website so people can download it, if you'd like.
Okay, thanks.
So here, first thing I'm going to show is that in C#, every method has to be in a class. There is no global methods, and there are no variables that can be outside of a class. So everything has to be scoped within. So this, very simple, is the obligatory Hello World program, where I have a class called app. And inside this class, I have my main method. And main is a static method because it's going to be called from outside, externally. We don't have an instance of app to use in order to call main. Main, in my example here, returns void, and it takes no parameters. And simply inside it, it calls console write line to display Hello World out to the console. So this is pretty much the smallest program that you could write and learn some things about.
So now, is main still a reserved method name in C# like it is in C++?
Main with capital M, lowercase AIN, because C# is a case-sensitive language like C++, but unlike VB in .NET, is the default. So when the compiler compiles the code, it's looking for a static method called main, and that's what it's going to use. But there is a command line switch. You can override it and pick a different one. And in fact, that's a useful tip, by the way. Some people put multiple mains in a single application to component test. And when you compile with a different switch to run a different main to test that particular component.
Oh, good tip. Yeah. Now, do you also have like an argv, argc parameter that are by default passed to this function?
Yeah, you can optionally, here I'll modify the code live, say string, it's an array of strings, args. And it's defined as I show here on the slide. So what this is, by the way, is this is the data type. It's a pointer to an array of strings, or a reference to an array of strings. I said pointer, but you don't actually see the asterisk, but it really is a pointer to it. When main is called, the startup code, if you will, has already parsed the command line and created an array of strings and passed the pointer to the array in. Now from within here, it's just very easy. I could do something like call args.length, and that would return to me the length property on the array, would return to me the number of elements that are in the array, and then I could just iterate it through it using a normal for loop, or C# has a for each, special for each statement for doing quick iterations.
That's new. That wasn't in C or C++.
That's correct. And I do have some code that demonstrates that as well. Let me go and find it here. So here's an example of some code that works with arrays. So I'll walk through this a little bit. First, I'm declaring a reference to an array of int32s in this example. IA, for integer array, if you will, is just a pointer, a 32-bit value or 64-bit value if they're running on a 64-bit system. And that is always initialized to null. References are always initialized to null until you explicitly set them. On the next line here, I'm newing up, or constructing, if you will, an array of 100 int32 values. New returns the reference to that, which I'm then storing in this IA variable. On this next line, I just show an alternate way of doing this, where I'm newing, again, an array of int32s, and then this special C# syntax, which is a little awkward when you first see it for the first time, has an open brace followed by the elements of the array, comma separated, of course, then a close brace. So that's just another way of doing it. And here, of course, it figures out the number of elements.
And that's just predefining the values.
Yes, that's correct. So now here's the for each, which is what brought me to this code in the first place. For each is a C# syntax. I'm sure all the languages, .NET languages, will offer it because it's a very common programming paradigm where you have some set of elements and you wish to iterate over them. So here I'm saying for each int32x, so x is my variable, int32 is of course the type in, and then I give my reference to the array here. So for each will automatically figure out how many elements in the array and write the additional code to each time it loops around go to the next element.
And that'd be the same sort of thing as saying, for I equals 0, I is less than IA.length, I++, which is kind of an awkward format if all you want to do is walk everything. So I'm constantly doing that exact same thing all the time, and I think this would be a lot easier. Right,
precisely. Although I'll give you this little tip out there, and that is that a lot of times, because for each is kind of cool, and it's really nice, it saves you a lot of coding. It also does another thing relating to casting, which is nice for you to have as well. So I generally, when I'm writing a loop, I usually start out with for each. And then as I'm working on my code, I then sometimes, frequently, I later find out that I need an iterator. I need an x that goes from 0 to the actual number. I need to know which element number. Yes. Yeah. So I end up rewriting this loop quite frequently.
Oh, really?
Yes, I do.
So, as a standard for loop.
Yeah, as a standard for loop, right. So sometimes it ends up being more work than what I originally thought it was going to be. But when it does work, and it is pretty frequent, it's really nice to have.
I suppose you could have just had a counter you stuck in there as well, but then that would have totally avoided the fact of having this for each to begin with.
Yes, that's right.
So what are some of the cool things you think that the C# has that our audience would say, well, that's the language for me?
Well, as Andrews pointed out in the earlier segment, it is, very component-based. It has events in there, it has interfaces in there, it has properties in there, and they're all first-class citizens. So there's no underbar property or anything like that that's in there. People out there should certainly get familiar with exception handling because all error processing in the framework and the base class library is done by doing errors. So here I have on the screen a little bit of code demonstrating how to do proper error handling. I have a try block, and again, you'll notice there's no underbars in front of the word try, because it's first class in the language. I'm newing a file stream object, which is a way to open a file on the disk. And here in quotes, I've given the path name of the file that we wish to open. Now,
wait, that's an error, though, isn't it?
No, this is just what I was about to point out. Is there's this very cool C# feature where you can prefix a string with an @ sign, and that turns this into a verbatim string, which allows me to just use a single backslash here instead of the double backslash. And for long paths, that's really a very common C++ programming error. People put in single backslashes instead of two, and it doesn't open properly. And in this case here, it would have been \n, which would have been a new line. All hell would have broken loose. So this is a really nice feature. So if file stream Unlike, for people familiar with Win32, create file function, when that function fails to open the file, it returns invalid handle value, or -1, to indicate a failure. In the .NET framework, when we try to open this file and it doesn't exist, this will throw an exception. So I have a catch here, where I try to catch the exception. My very simple catch just displays a message out to the console, which probably you wouldn't do. You'd probably do something else. And then I have finally, which is code that's guaranteed to execute. So if I have more lines of code in the try that actually use the file after having opened it, the finally would go and explicitly close the file later on. This is also a really nice thing that Win32 and even C++ doesn't have, which is the ability to have a try, a catch, and a finally all as one clause to really sum up this operation. We never had that before.
And error handling, I think, is pretty important for people to do in their application. As they get more and more complex, there's just, more possible things that could possibly go wrong in trying to create a file or something like that, especially using other people's objects and so forth like that. Now, does this also mean that in writing a C# application, you need to make sure that your functions and methods are properly setting the exception or throwing an exception out so people can catch it?
Well, absolutely. When you write a function, good programming paradigm states that you validate all the parameters that get passed to you. And if any of those parameters are not what you expect them to be, then you should definitely throw an exception. And there are a ton of exception classes already defined in the base class library, so it's easy for you to just use an existing one. But you also do have the ability to define your own exceptions. Maybe you're looking for a customer in a database and you don't seem to find their name. You could create your own bad customer exception and throw that somewhere in your code.
Or you just don't like the customer's name, perhaps. It's a bad name of customer.
Yeah, something like that, right? If it's Robert, you always want to throw.
Yeah.
If it's Robert.
So where do you think C# is going as a programming language? What are you noticing your customers doing when they're taking your classes and so forth like that? What do they think of it?
Well, I really think it's going to gain an enormous amount of momentum. As I said, I've been pretty much programming it exclusively for the past year. Occasionally I'll do a C++ thing, but very rarely now. And I also tend to believe a lot of VB programmers will move over to the language as too, because it lets them tap more into the common language runtime and functionality that's there. I really think it's going to gain an enormous amount of momentum and really be used heavily. In my classes, certainly everybody seems to enjoy it. In fact, some people said they came to the class because they thought it was C# programming class only, but then they were happy to find out it covered the frameworks in the class library as well.
So speaking of the .NET framework and class libraries, what do you think of those and how they're assisting in application development?
I mean, the platform, I think it's just phenomenal. I've been using the whole platform for a year, and there's a large project that I was been working on recently for Microsoft to be kind of a showcase for lots of Microsoft technologies. And I was working on it with one other guy, his name was Tom, and we would get together in the morning and we would go on a whiteboard and we would say, so here's the kind of features we're going to add today, and we would discuss it for a while, and we would say, so this is going to be our goal for the end of the day, and usually before lunch we'd be completely done. We always beat our expectations of having it done. We were in shock.
Do you think that was a combination of C# and .NET that was assisting you in doing that?
Oh, for sure. There's no question, because all the plumbing is gone. All the, how do we expose this thing? Should we make this a method? Should we make it in a DLL? Should we make it a COM object? What type of interface should we have? All those kind of issues of how do you wire this up and pass the pointers around and hold on to something so you can sync and get a sync to somebody else to notify them. All those issues are just built right into this platform. So we were always, we'd work for an hour, we'd get something done, we'd be amazed, we'd stand up and we'd high-ten each other, and then we would sit back down and we'd start to add something else. It was just incredible how our productivity. Wow. And it was so much fun too. We were really doing amazing things with graphics and alpha blending and all kinds of stuff, which I'd never done before, alpha blending kind of stuff. I'd worked with graphics, but it had been many years. And using the system.drawing classes in that namespace. We were able to construct these images and overlay them and alpha blend on them and then send them back from our web server back to any client running on any machine. Doesn't even have to be a Windows machine. I guess
it kind of brings a good option. I mean, so far we've been talking about application development using C# and the .NET framework and stuff like that. And I know that you're a true application programmer writing Windows application, standard GUI stuff. Well, all of a sudden we've had the web has come up, and everyone's thinking about writing web applications or HTML-based applications running inside of a browser. But now you meant you in one word there, your one description of your product, you're talking about having this alpha blended standard Windows graphical application, but then also accessing the web and tossing things to other systems in that fashion. How do you view the traditional application development environment and people like you and I who develop Win32 applications and so forth, and this new web application model blending together with .NET?
Well, actually, for this particular thing I was doing, it wasn't a Win32 graphical app. It was a web form, if you will.
Oh.
Yeah, it was a web
So
form.
it wasn't even a traditional Windows application.
Well,
it sounded like it.
Really,
though.
what it was, it actually has a more complicated architecture to it than that. It was actually a web service, and I think it's one of the first public Microsoft web services that's free. So I'll give you the URL. So anybody can go to it and they can fiddle with it. And it's terraserver.microsoft.net.
Okay. And I'll put that at the bottom of the transcript so people can take
that's good.
click on that.
So that is a poster child for a lot of Microsoft technologies, including Windows 2000 Data Center and SQL 2000 and IIS and ASP.NET and the .NET frameworks and web services and web forms. All that stuff is on that site. So we built, this guy Tom and I, 3 web services that are on that site. There's a TerraServer web service that has mapping information and shows imagery and tiles in relief map, topographic maps, and regular images photos. Then we also have a census service, so you could go there and put in a latitude, longitude kind of thing, get the city back and number of people lived in that area. And we also had a landmark service, so giving a rectangle in latitude, longitude, you could then get back all the hospitals or schools that are within that particular region. So it's 3 separate web services. They could have been implemented by different companies, but they were really all implemented by us. Then we wrote a web form app, which could have been written by any company, but again, was written by us as proof of concept. And it spoke to those 3 different web services and could get the tile information from TerraServer, get the landmark information from the landmark server, and then we were able to overlay them on the map.
Using alpha blending.
Yeah, well, yes, using alpha blending. And then that was sent back in a web form back to a client running on any machine. We even added the stuff so if you hover over something, the tooltip would come up and tell you the name of that school or the name of that hospital that was on the page. This is, well, I thought it was an incredibly powerful paradigm. The fact that the client could be any machine running any operating system at all, and we were using the Windows 2000 features in its GDI Plus for doing alpha blending and those types of advanced graphics manipulations on the server, but then we just sent over the bitmap back to the client. I think that was incredibly powerful, and again, we were incredibly productive. I see a lot of applications moving in that direction.
So you really like the whole web model of doing web applications?
I do.
Yeah. Even though you're a traditional Windows application developer, you've bit the bullet and you're going the other direction now.
I have. It just runs everywhere. It runs everywhere, and doing this work on the server. And then the distributedness of the whole thing, right? As all these, the servers could have been on 3 separate machines. Oh, and then the SQL server that maintained all the stuff could have been on yet another machine. And the web form server could have been on yet a different machine and could be fine-tuned by different companies to use this material in any way that they see fit to produce these really rich apps that run literally anywhere where you have internet access.
Wow.
That's incredible. It was just incredible.
Something tells me you're impressed by all this.
Yeah, a little bit.
So, are there any final remarks you think that a developer on the audience, someone out there that's on the edge of his seat, wanting to get into C# and when you start writing some of these .NET applications, needs to really understand before they take some of their first steps?
I think one of the biggest issues that's going to come up for developers out there is that they have to realize, and they'll probably just learn this from experience over time, that the language is exposing the features that are in the runtime in the base class library. And a lot of people will look at C# and maybe they'll try to do, or some other .NET language, and maybe they'll try to do something that language doesn't provide, and they'll therefore think that's just not possible. Like, for example, in C# by default, in C#, all arrays are based at 0 indexed. But the common language runtime supports arrays that have any lower bound and any upper bound. So there is a way in C#, but really you kind of leave C# and you go to the base class library to construct an array that can have a lower bound you set and an upper bound that you set. But C# naturally doesn't provide that for you. So you just have to learn over time what it is. And a lot of times you're able to maybe use some other language or get access to the underlying system that a language on top of the runtime, for some reason the designers have chosen to not give you access to.
So it's, I mean, similar to, by understanding the capabilities of underlying runtime and all the different features there, you can then map that to whatever language you're currently using and understand whether or not it's giving you the power you want.
Yeah.
And like, for example, when I write web pages, I always write it in raw HTML because I know what the capabilities are. But if I had to write it in front page, I know that front page has its own mindset of what it looks at the web page wise, and I know what it can and can't provide to me. And every once in a while, I've got to jump back to raw HTML and add something in that fashion or other tools. It's the same thing that it
Right,
seems
same
like.
thing. And sometimes the feature is there too, but it goes under a different name. For example, in the common language runtime, a virtual function is called family. And then to create a virtual function in C#, you would say protected. Right? Or not protected, but it's protected. Protected is in C# with the equivalent of family in the common language
right?
runtime.
Yeah.
Yes, it gets confusing. See, already I'm messed up.
But so it sounds like the base idea is just get to understand what the tools you're working with and how well they have operation underneath to the .NET framework.
Yes.
Well, thanks a lot, Jeffrey. I really enjoyed talking with you again, and I'll have you back on the show again sometime in the future.
Oh, my pleasure. Thanks for having me.
So that's how the programmer thinks about C# and the .NET framework. Hopefully Jeffrey gave you some good information that you can use in understanding your development aspects. He talked about a couple of URLs and some sample source code and stuff like that. I'll be sure to include that at the end of the transcript. So stay tuned for the rest of the show and see what's going on.
Microsoft is, of course, known for its operating systems, applications, and server products, but I'm sure most of you out there, or many of you out there, your true passion lies with the fun stuff, games. With me today is Adam Wachs. He is Product Unit Manager of Role-Playing, Adventure, and Technology. Right away, with a name like that, I know your group must be tons of fun.
We have lots of fun.
So tell me a little bit about the group and your position and what you do there.
Well, I'm the product unit manager, which means that I have most of the functional areas, dev, test, and program management that report to me. And we do role-playing games primarily, adventure games. So the kinds of games that, typically young boys play, lots of Dungeons and Dragons sort of environments and things such as that. So, but of course, we all are game players as well, so we have a lot of fun while doing our jobs.
Sure. So what type of games has your group come out with so far?
Well, the biggest one we've done recently is called Asheron's Call, which is what we call a massively multiplayer online role-playing game where any night in the evenings there's probably 15 or 16,000 people that are up on the internet playing this game, and they're in a world with thousands of other people exploring the world, looking for treasure, killing monsters, working together, things such as that. So it's an exciting environment for people to be playing in.
That's excellent. So what type of games is your group working on for the future?
We're working on a game called Dungeon Siege, which is another role-playing game, although it's not on the internet. And that's a game where you essentially have to try to kill the evil that has taken over your land. And it's a process where you start out as a farm boy, and you're in your farm, and the monsters come in and kill your chickens and burn down your house, and so you're angry. So you have to go and try to figure out why they come out of the mountains, and you slowly make your way around the world and find this ultimate evil bad guy, and you have to take him out.
So what would you say is the most challenging aspect of your job right now?
Probably the biggest challenge is really discerning the hits from the misses, as it might be. I mean, it's just like the movie industry that, you can't tell for sure what people are going to get excited about and what really catches people. And so it's really kind of an art to kind of find the game and look at it and say, that's it. That game's going to be a big seller. And then, sign those guys up and make it happen.
So how do you take customer feedback into play with the type of games that you're designing for the future? Versus just your own ideas of what you think would make a good game?
We have a number of steps that we actually bring people in and get their feedback on very early a lot of times. We have focus groups early on. We just did some of those for the Xbox products that we're working on, where we'll take our target audience. In this case, we had two different groups, 16 to 18 and 19 to 24. And we just kind of talk to them without them knowing it's Microsoft or without them knowing about what the game is exactly. We ask them and we show them the art and we say, hey, is this cool or not? What do you like about this? What don't you? So that's kind of the first step, is when we do focus groups. And then we kind of go back and take that feedback into account and come out with a beta product where we essentially give it out more broadly and let people actually play the real game. And then there's news groups, and we chat with a lot of people and understand, again, what things do you like, what things don't you like? Is there something that we should change to make the game cool? And we have some time to do that, and then we actually ship the game. So we have a couple, 2 or 3 different times that we get user feedback. As we move forward with like second versions and stuff, of course, we really listen to the user community that from the first version and try to make the games appeal to those guys again to make them buy it a second time.
Right, sure. So what is your favorite Microsoft game?
Well, I'd have, of course, say Asheron's Call because it was ours.
Sure.
Another game that I love to play is Age of Empires: The Conquerors. Is just a new game that just came out recently, and we actually play a lot of that at work because that's a real-time strategy game, and so we typically will have 6 or 8 of us, and after we're done with our day, we'll actually play for an hour or two and do research as it might be. So, yeah, so that's a great game as well.
So I imagine you must play a lot of games outside of work.
I do. My wife actually usually goes to bed about 8:30, and I play from 8:30 until about midnight or 1 o'clock in the morning. So it's amazing that she lets me do that, but she does. And of course, it's research for work, so so it's important to my job.
So what other hobbies do you have outside of work?
I do a lot of hiking and camping. One thing I enjoy is I've just bought some chainmail, so for like Halloween costuming, things such as that. So my son and I both went as knights this year for Halloween. We were fully decked out in our chainmail and our swords and helms and things such as that. So that's another thing that I enjoy is learning about earlier times, medieval times, and how people lived and the kinds of things they did and things such as that.
So you can definitely incorporate that to your work. So,
oh, absolutely. Yeah. Of course, I've played Dungeons and Dragons and Rollmaster and things such as that for years and years as well as a kid and still today.
Right. Sure. So you said hiking. Do you like hiking in the Northwest? It's a great place to do that, of course, living here.
Yep.
Are you a native, Seattle native?
Actually born and raised in Seattle. I'm one of the few ones here at Microsoft.
It's true.
Yeah.
So before you were product unit manager at Microsoft, what other types of jobs have you done here, and how long have you been here?
I've been here something on the order of 13 years, so quite a while.
Yeah.
One of the old timers. I started out in product support doing C programming support and moved from there into the developer relations group that kind of talked about our future operating systems to the development community. Then moved into the MSN group where I was a program manager, and then decided, you know what, I've been here 10 years, I want to go do something that's really fun and exciting. And so at that point I moved into the games group and started working on the Internet Gaming Zone, which is a place where people get together and play all kinds of different games, from the hardcore games like Asheron's Call to Hearts and Bridge and Cribbage. And then I've moved on from that onto this role-playing adventure and technology group.
Right. So how would you say, or what would you say you picked up and learned from the previous job that helps you with your current job?
Oh man, it's interesting. It's always been a learning process, and it seems in every job that I've taken, I've always learned a lot. I mean, first of all, I think the technical underpinnings of doing the C stuff very early on and understanding the operating systems. I was actually one of the original Windows OS2 or OS2 support guys. So I was essentially one of the guys that helped people write OS2 applications, and then moved on to Windows NT and essentially was one of the original evangelists for Windows NT. So really learning a lot about operating systems, what they can do, understanding the technical underpinnings was really important. As I moved into like MSN, really understanding the internet and where the internet was going and how that could impact gaming was something that was important to me, and seeing kind of the vision of how that could affect the gaming world and coming over and working on the Internet Gaming Zone. So, and then through that, as I played a lot of games and things such as that, I've grown, comfortable with understanding the games market and where it's going, and ready to kind of hopefully do this job well.
Right. Where would you say the future of gaming is heading at Microsoft or in general?
Well, I'm biased, of course, but I think that the online space is where you're really going to see a lot of additional innovation, a lot of additional excellent stuff, like that in the Xbox probably. Let me talk about the online space first. I mean, when you play in a game against an artificial intelligence, that's fun. But when you can play against other real humans, it's a lot more fun. So, it's always exciting because you're kind of exploring someone else's mind and trying to figure out how you can find the hole in their defense or whatever. So that's fun. The other really exciting thing that we're doing right now is Xbox. So we're working on a console that's going to come out from Microsoft, and that's kind of a whole new environment that Microsoft's not been in before. And so we're working on a number of games for that console, and that's exciting too, because moving into a new environment with new kinds of games, and it's just exciting.
Well, Adam, it sounds like you have an incredibly exciting job here at Microsoft, and thanks for taking the time to talk with me today about it. I'm sure you've made many developers' day out there.
Thank you very much.
You're welcome.
Well, that's been another episode of the MSDN Show. Hopefully you understand a little bit more about the C# programming language and how it can help you write better applications.
Stay tuned for the next episode on ASP.NET.
And until then, we'll see you on the web.